Good morning. How are we doing today? All right, today we're going to move into chapter 6, and we're going to talk about ratios and proportions. So let's start off with actually defining what a ratio is. So a ratio is the quotient. All right, so it's going to be a fraction, is the quotient of two numbers. Okay? So an easy one would be, like sometimes you see to it as like 1 to 2, or 1 over 2. And sometimes we even just write it like this. 1 with the colon there, 1 to 2. Okay? Real life applications of this, we've all seen it before. If you've ever driven in a car, that would be miles per hour. So if you were traveling, let's say, 25 miles per hour, well, that is a ratio, okay? And that ratio looks like this: 25 miles per 1 hour, okay? Meaning that if you were to travel for 1 hour in your car, you would travel 25 miles, okay? So now let's look at just some other examples, okay? So we'll do some like actual like word problems, I guess, right here. So let's write a ratio for each phrase, okay? So the first one, the ratio of 3 parts oil to 7 parts gasoline. Okay? So what would that look like? Well, you can write it as 3 over 7 or 3 to 7 or 3 with the colon 7. Okay? The most important part is if you're writing these in the 3 different ways, you just keep it consistent. If you write the 3 first, then make sure the 3 is first in every single example here. Okay? In fact, this 3 parts oil to 7 parts gasoline, I just did that the other day. I have a weed whacker, and when I add gasoline to it, I actually pour in this oil stuff. I don't even know what it's called, but it just mixes the oil in with the gasoline. That way, it keeps the engine from like getting overheated and stuff like that. And it says use one of these containers for every 2 gallons of gas. So what I have to do is get a 2-gallon gas thing and just pour them together. If I had a 1-gallon gas container, then I would only pour in half of it. So let's try one more. The ratio of 40 minutes to 3 hours. Okay? So this would look like this. I'll just use the fraction one. So it would be 40 over 3. Okay? All right? And sometimes what you want to do is you always want to try to reduce this. All right? So if we think about 40 over 3, there's really nothing we can reduce there, so it just stays 40 over 3. All right? So I guess I didn't need that there. Sorry about that. All right? So let's move on. Let's move on. So how about this? How about given the triangle, okay, find the ratio. So we're going to find the following ratios. All right. So let me draw this real fast. Okay. So it's a nice right triangle there. This is going to be 6 meters, 8 meters, and the hypotenuse will be 10 meters, okay? And for part A, let's find the ratio of the length of the shortest side to the length of the largest side. Okay? So if I look at the triangle, okay, the shortest side is going to be right here. It's going to be the 6 meters. Okay, so that's the shortest. And the longest will be the hypotenuse, which is 10. So it's going to be shortest 2 longest, which underneath would be 6 meters to 10 meters, or 6 over 10 meters, all right? And that's going to reduce down into, well, they're both even, right? So we could take a 2 out of each. So it's going to be 3 over 5, okay? There you go. All right, how about part B? We'll look at part B for this, all right? So let's find the ratio of the longest side to the perimeter. Okay, well, we know, looking at the picture here, the longest side is still going to be the 10 meters. So let's erase this real fast so we don't get confused. All right. But now we need the perimeter. We know perimeter is just the outside distance, all right, that encompasses the triangle. So the perimeter is going to be 10 meters plus 6 meters plus 8 meters. So let's see here. Let's do this easy. 6 plus 8 is 14. And 10 plus 14 is 24 meters. So this is going to be the longest to perimeter, all right, which is going to be the longest side, 10 to 24, or 10 over 24. Oh, I wrote 25 by accident, sorry. 24. And let's reduce that. Well, that's going to be 5 over 12. Okay? All right. So I hope that helps. So now what we're going to do is we're going to transition into how to solve ratios, okay? Now, when we have two ratios, so a ratio equal to a ratio, all right? So I've got the word with here, how to solve with ratios. So when we have a ratio equal to a ratio, these two things together form what we call a proportion, okay? So another way to say this is a fraction equal to another fraction is I can't spell today, is a proportion, okay? And solving proportions, very, very simple. It's very easy to do, okay? So this is the only time you're allowed to do this. Students always get confused. They always forget when you're allowed to do this, and this is the only time. So you ready? To solve a proportion, cross multiply. Okay? And what that means is this, all right? What that means is this. Let's say I have A over B, and that equals C over D. Notice we have a fraction equal to a fraction. Another way to say that is a ratio equal to a ratio. To solve this, we're going to cross multiply, which means you're going to multiply A times D and set that equal to B times C, okay? And that's it. Then from here, you would just do your normal, your normal techniques for solving linear equations, okay? That's it. A times D equals B times C, cross multiplication. And I want you to really be aware of this. You only have one fraction on the left, and one fraction on the right, okay? That's the only time you're allowed to do this cross multiply thing. So let's look at some examples, okay? So 3/8 equals 63 over x. Notice one fraction on the left, one fraction on the right. So what we're going to do is we're going to cross multiply. So we get 3 times x equals, and then we're going to do 8 times 63, okay? Now, 3x equals, let's solve this. 3x equals 8 times 63 is 504. And then divide both sides by 3 to give you x equals, well, I'm going to do that. I'm going to do this division off to the right. 3 goes into 5 once. It gives me a 3. Drop down to 0. 3 goes into 20 how many times? I think it's 6. It's going to be 18. Drop down to 4. And 3 goes into 24 8 times. So x equals 168. Okay? Now, here's what's beautiful about this. I'm going to erase this division. Here's what's nice about this. Watch this. Watch this. 3 over 8 equals 63 over 168. Okay? Watch what happens when I cross multiply here. So I get 3 times 168 equals 8 times 63. We already know 8 times 63 is 504. Well, guess what 3 times 168 is? Well, that is 504 as well. And notice 504 on the left, 504 on the right. So that's an easy way to check yourself. Okay, that's an easy way to check yourself. All right, let's try another one here. Let's try another one. Okay, 45 over x equals 5 over 7. All right. Now, I want you to see here, when I cross multiply, every single time I write it out. Okay, I write it out. I don't do any shortcuts here. Okay. So now 45 times 7. Well, I got to do that. So 45 times 7 is going to be 315 equals 5x. Okay. Now I divide both sides by 5. 315 divided by 5 is 63. Okay? Remember, the key, I think, is right here. Is to write this step first. All right? It doesn't take long to write it. It just helps. And you could see where it's really going to be beneficial is this example right here. 2x plus 1 over 7 equals x minus 3 over 5. Okay? So, once again, look on the left. One fraction. Okay? We only have one fraction here. Okay? Look on the right. One fraction. All right? So, we can cross multiply. We're allowed to do that. All right? So, I'm going to cross multiply. And remember, I write out that step. 5 times 2x plus 1 equals 7 times x minus 3. Okay? Now, do you see why writing out that one small step is so beneficial? Because now I can see that I have parentheses on both sides, which means I need to use the distributive property. Okay? I need to distribute. So 5 times 2, 10x. 5 times 1 is plus 5 equals 7 times x is 7x. And then 7 times negative 3 is minus 21. Okay? So now I'm going to get the variable terms on one side, constant terms on the other. So I'm going to add 21 to both sides. Oh, I wrote 12 by accident. Add 21 to both sides. That's going to give me 10x. Let me scroll up here. 10x plus 26 equals 7x. All right. Now I'm going to subtract 10x from both sides. It's going to give me 26 equals 3x, negative 3x. Okay? And then I'm going to divide both sides by the coefficient in front of the variable term, which is negative 3, to give me x equals negative 26 over 3. Okay? All right? So sometimes, the answers, they don't come out to be these perfect whole numbers, but that's okay. We could deal with that. Okay? We could deal with that. Now, the last thing I want to go over, we'll do an application problem. Okay? So problems modeled by proportions. And we use these all the time, okay? So a really good example here is when you look at a map, all right? So on an architect's blueprint, or how about just this, we'll say on on a map, 1 inch corresponds to 4 feet. Okay? 1 inch corresponds to 4 feet. All right? How long is a wall represented by a 4 1/4 inch line on the blueprint, or on the map, we'll call it. Okay? All right. So, let me see if I can find, let's see, let's scour the internet real quick. All right? And I'll show you what I'm talking about here. All right? Because if I just give you the problem, I don't think that's the best. I want to show you. So, legend on map. All right? So when you look at a map, okay, normally there's a little legend, okay, and a legend is just it's a visualization key. It tells you everything you need to know about the map. All right. So let's see if we can find some images here. All right. So let me see here. Let me be more specific here. Let's look up a road map. Look at Texas here. See if Texas got anything for us. Oh my God, look at this website. It's horrible. Oh boy. That does not look good. Oh, Texas failed us. Not good. Okay, here we go. Here we go. This one's good. All right. You're gonna. There it is. All right. So if you could see here, all right. Let me see if I could zoom in here a little bit. Do you see where it says the one semicolon 70,000? Okay, and then you have the big bar graph at the very top here. See if I can highlight it here for you. See, you can see where my cursor finger is pointing. All right, right here would be the proportions. Okay, right here would be the proportions. All right. So when we're talking about here with this example, that's exactly what we're talking about. 1 inch corresponds to 4 feet. That's a proportion. All right. So 1 inch over 4 feet. Okay? So what they're asking us to find is how long is a wall represented by a 4 1/4 inch line on the map? Well, the key to proportions is this equal sign. That's the key. If you see on the left-hand side, our fraction right here is set up as inches over feet, then that means on the right-hand side, it has to be inches over feet as well, okay? Because they're equal to each other. So I'm going to put 4 1/4 up here. What I don't know is how long is that wall and how many feet is that wall, okay? So an easier way to look at this is just 1 over 4 equals 4 1/4 over x, okay? All right? And what I'm going to do here is before I even cross multiply, all right, what I'm going to do here is I'm going to convert this 4 1/4 to an improper fraction. So 4 times 4 plus 1, well, that equals 17. So it's going to be 17 over 4. Okay? So I get 17 over 4 all over x. Now I'm going to cross multiply. 1 times x equals 4 times 17 over 4. Okay? So I get on the left-hand side x. Now on the right-hand side, I have 4 times 17 over 4. Look at the denominators. they will reduce down into a 1. So I get x equals 17 feet. So that wall is 17 feet. Okay? So I hope that makes sense. All right. I hope we can see how we use ratios to label things, and then how we use ratios together to form proportions and how to solve them using cross multiplication. And this is a short lecture, so I will see you in section 6.2. See ya.